Okay, good morning, good afternoon, good evening, depending on where you are in the world today. I'd like to thank everyone who's joining us. So welcome to today's CNCF webinar, Discover, Deliver, and Secure Your APIs Anywhere. I'm Christy Tan, Marketing Communications Manager here at CNCF. I'll be moderating today's webinar. We would like to welcome our presenters today, Jakub Pavlik, Director of Engineering at Volterra, and Madhukar N, Lead Solutions Engineer at Volterra. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can at the end of the presentation. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow participants and presenters. Please also note that the recording and the slides will be posted later today to the CNCF webinars page. That's cncf.io/webinars. With that, I'll hand it over to Jakub and Madhukar to kick off today's presentation. Take it away, guys.
Okay, great. Thank you. So, hello, everybody. It's great to be presenting here today. My name is Jakub Pavlik, and I am Director of Engineering at Volterra. So, I am responsible for running all our infrastructure software globally, and I am here today with my colleague, Madhukar.
Hey everyone, my name is Madhukar and I'm a lead solutions engineer at Volterra.
Okay, so let's get started. So first, I will shut down my video because you want to hear me. And I'm actually running some demo on the laptop, so I need the full bandwidth. Okay, great. So our presentation, we would like to show you how you can efficiently discover, deliver, and secure your APIs anywhere, and how easy we can overcome some of the challenges with distributed API. Now, before we start, let's go over 3 building blocks of the needs for modern applications and how those needs are changing. So if we look into the infrastructure space in the past decade, what was happening is that people were actually migrating from the centralized data center architecture into the public cloud, and they were trying to create hybrid, like running it in AWS, and there were various reasons like cost optimization or time to market. Now, if we look in the future, the trend continues to consuming public clouds, but people are actually looking also on the multiple providers. And it is from the various reasons where, for example, they don't want to be locked into particular vendor, or some public cloud offers much faster or better performance of particular service. So they want to distribute it across multiple clouds. And also with the emerging of the edge computing, they need to run same type of applications in the edge, which brings completely new challenges comparing to the centralized data center where it was before. Now, if we look on the how actually applications were architectured in past 10 years, people were trying to take their monolith and run it in the VMs. Just lift and shift. I saw many projects in the enterprises where they just took it and they wanted to run it either in private OpenStack cloud or in public cloud, and they kind of make it work their monolith. Now, continuing on this track, we are getting in the world with the microservices and serverless, where it requires completely different approach for how applications should be architectured, deployed, secured, and transformed. So it brings completely new challenges, and the old way of doing things doesn't really work. Now, my last point is related to the network, where usually traditionally secure policies and connectivity was managed at the security level, at the HTTP level, or at the IP level, and there were efforts to do micro segmentation and enforce it on the network level. But what is happening and what will be our presentation about and what we will show you in a very nice cool demo is that all those apps are now API driven. APIs are everywhere. And if we look on all the traffic between all these APIs, they are usually gRPC or the REST, and they are multiplexed on the same network port, like 443 HTTPS. And as a result of this, the network level security and connectivity is not very useful anymore, and it requires completely different approach of doing things.
So as Jakub was talking about the rise of adoption of microservices and serverless, so APIs are becoming the default factor for service to service communication. So if you think about it, it's just not the app which runs on your public cloud, or it could be edge cloud, right? It is anything which you're carrying around, maybe your iPhones, tablets, or the devices which you're wearing, or the devices which you're driving, or like cars which you're driving, are all day long are using basically APIs to talk to public clouds. And this is just the list of companies which have been successful in using APIs in a way that they are making like contributions to their industries as well. So they're becoming successful because they are using APIs in a way that they are easily scalable, and they have so many consumers around the world, and they are able to scale for all those consumers as well. So next slide, please. So now that we talked about the significance of APIs, so every company which adopts APIs as the universal way of communicating between internal service, or it could be external service as well, will have hundreds of APIs exposed publicly and thousands of APIs privately for internal service communication. Depending upon the number of consumer per geographical location, like these, there will be hundreds of APIs which will cause trillions of connections. And this would increase just the complexity of managing these APIs. So, and these APIs could be served from anywhere. It could be from your public cloud, it could be from your on-prem, it may as well be from your the home offices, or it could be from edge cloud as well. Next slide, please.
Yeah, so if we look on the challenges with the management of the APIs and microservices, so with the APIs, there is few big challenges. The first thing is multiple API version control. So people running different versions and they want to serve different client versions and access different API versions. They want to do canary upgrades when part of it runs on the old API, second part runs on the new API. So you need to make sure that all this communication works properly, which is sometimes very hard in the distributed environment. Now, looking at the second point, discovering and management of distributed APIs is a big pain. Even if you look at the one cluster, usually like Kubernetes cluster, and you have tens of the applications and you want to talk to them. Now, if you want to run it 10 times in 10 different locations, it is multiplied by 10, and it's very hard to actually discover them on the central place and keep other locations, get to know where they should access, how it is consumed, and also have some basic visibility on what is happening and when communication is flowing, which goes together with multi-cloud secure API communication, where I can give one good example where let's say if we look on authentication and authorization, I saw the example where company wanted to implement mutual TLS, like MTLS between all their APIs. And even if they made all application to be able to consume certificates and establish the MTLS communication, and they successfully distributed all the certs, then they were struggling on actually revoking the certs and the life cycle of the certs, and also making sure that if one cluster was compromised, people could not get certificates and access other clusters. So it needs some layer above, which will help you to manage all this life cycle, and not only the authentication, but also the authorization. And the last point is traffic management and scaling, which people, I am sure they are aware of, traffic shaping and sending 20% of the traffic to this location and 80% to this cluster, or based on geographic location, you want to send the requests to the closest point. So those are also quite big challenges which need to be solved.
So now we were talking about the rise of microservices, right? So every organization, usually it's just not like 5 or 10 microservices which they are running to basically host their SaaS or services. So it is usually in hundreds and maybe in thousands as well in some cases, right? So when you have those many microservices which are running at different locations, you basically need an end-to-end visibility. Now we talked about how APIs are becoming the default to and like service to service communication. So in that case, each service is talking to another service using a particular API endpoint. So just visualizing it, understanding what is happening is really important. It could be for multiple purposes, for debugging, for security, for making sure that like, for example, for an internal services talking to some of the SaaS APIs, it is using the right authentication mechanism. So it's really important to basically visualize those API communications between those services. Now, most of us as developers are doing some or the other webhook development on our laptop locally, and we may want it to be exposed outside, or we may want some traffic coming in as well. So just when we are doing it very locally, it's hard to basically show the visibility and security at the local sandbox level or a development environment level. Same thing with testing the mobile apps on laptops. So just the developer workflow of running a service, like just running maybe a Golang service and just building it is very basically, it's hard to visualize, trying to understand what are the different API endpoints, where it is talking to, just to get the entire picture of it. And now, like, what another thing which is important with microservices is this is usually people think of them as, like, for example, users usually have all these different roles, and then when users have roles, so there is an RBAC rules. In a way, you basically control the authorization of who can access which resource, right? So similar philosophy should be adopted in APIs as well. So APIs need to talk to another service, like one service will talk to another service using APIs. So there should be some way of authorizing it, whether it is supposed to talk. If there is no need of communication which needs to happen, then we need to basically stop that communication using some kind of OTZ as well. So doing that at anywhere, like even public cloud or laptop or on-prem is very hard. Next slide, please.
Yeah. Okay. So if we look on what is available today, if we want to achieve these goals, so you can go and take a look on the service meshes, where if you deploy the service mesh into single cluster, you will get the logging, observability, API management. You can do almost all things what we were describing in previous slides. But when you start adding more clusters, uh, it will become the operational challenge, and you actually have to build in-house know-how of how to run service mesh across multiple clusters and make sure that it always works. You need to keep maintaining it. You need to keep updating it, and sometimes it's kind of hard because your ultimate goal is to run your app and have all these functions, and you don't want to become like service mesh expert and have a team who will just manage service meshes. So it needs to be simplified. uh, on the other hand, distributed apps requires common API frameworks for the deployment management across the heterogeneous environment. So if you start moving between two public cloud providers, then your data center, and then you might go to edge, you need the common way of the API and the way how you will do things, and you don't want to use different management plane of the different cloud provider. So this is also like one of the problematic thing when you would like to build something like this. And now the last point, emerging the cloud native edge requirements. So most of the people now I see they focus to run the edge, and what I see, they just take K3s, they started on Raspberry Pi, and they think that they have edge computing. But if you think about it, you need to, it is not about just start Kubernetes with some container somewhere, but it's also about how you deliver a unique identity uh, to that app, how you establish secure communication channel, how you make sure that those applications talk on doesn't visible each other, so multiple stakeholders can actually deploy and have multi-tenant environment in that edge. So there is many challenges where I can see just deploying the app in the edge, like Kubernetes pod is 30% of the problems what you need to solve.
So we have been talking about the rise of microservices and APIs, right? And then when everybody is working from home right now, they need a way to basically either deliver few of the APIs which are running on public clouds to their laptop so that they can do actual testing on real data. So for doing that, it's the solutions which are available right now are really complex. So you need to have so many service needs to be installed on laptop, but laptop was not built for hosting those many services. So it's just the solutions which are available for API delivery on your branches, branch offices, or small homes or home offices are actually are complex. And then the solutions which are available, they do not provide enough visibility and security which is needed for running that service on your dev environment for developers. So for example, the amount of security you can actually use on public clouds or on prem is not same as what you use on your laptop. So you have very limited tools which you have at your disposal when you are developing locally. And then usually we all have unit tests which are running, but we really want the new feature or whatever we are developing to be tested against an actual development cluster. So and these development clusters are running on some public cloud, so usually you need to basically go commit and do merge, and then you deploy the new version of your microservices onto the cluster, and then you can actually test it, and that may cause more problems as well. So if we actually include testing of your small feature right in the initial stages where you test across a real cluster, then you can actually reduce the amount of time, like the amount of time you needed to basically fix those bugs when it appears on the development cluster. So you need an easy way where you can locally do an unit test, and build it and test it against a real cluster with a real data. Next slide, please. So what do we need, right? So what we need is a universal stack for API discovery, control, and delivery, which is centrally managed but globally distributed. So what I mean by that is we need a common way of managing APIs. It shouldn't matter where the origin server for those APIs are or where these API needs to be securely delivered. These origin servers could lie on public cloud or edge cloud or on-prem or maybe on your laptop as well. So you need a common mechanism to basically discover those, apply security policies uniformly, and deliver it at various locations. Next slide, please. So what you actually need is you basically need a single stack which can integrate the different services which you usually would have run, right? So a single stack which could consolidate all the services, and then you need a SaaS based APIs so that you don't need to worry about, okay, the different lifecycle management at different environment. You can trust on somebody who can actually do the lifecycle management of all your applications or all your services running on different environments. And then now we have been talking so much of different heterogeneous environments. You need a common tooling. It's like depending upon which cloud you're running or depending upon which orchestration you're choosing, you shouldn't change your tooling, which is critical for any kind of any kind of operation. And then again, we need a way to basically enforce a centralized policy for all these environments and also visualize it, right? And visualization is critical for day two operations. And then this platform is basically should be able to be used by different teams in a way, in a way that it's like, for example, NetOps can come in and then do his own provisioning of those devices. DevOps can come in, spin up these clusters. SecOps can come in and then create all the security policies which he needs. And next screen, next slide, please.
Okay, so now let's go into the demo part where we prepared two views of the workflows of the demonstrations. So I will be presenting as a developer and Madhukar will be as a DevOps SecOps guy who will continue in the next part. So what we prepared here is we took some example hipster shop, which is online boutique application. It is a Google example microservices demo. What you can see here, it is typical microservices stack where there is some front-end service. Front-end service talks to currency, checkout, payment, product catalog, so many other services. And it is all running now in our shared development environment. So we have EKS cluster in our AWS VPC with this set of microservices and Kubernetes services. And now what I want to do as a developer is I want to develop a feature, new component into product catalog. So as you can see, product catalog, 3 services are talking into the product catalog. So if I zoom out on this slide, I am having my EKS cluster here, and I'm using our ingress egress Kubernetes gateway, which does service discovery. Now I have 2 options. So one option is to build the Docker image with a new feature and just rolling update it into the cluster and do some verifications. But because it's a shared cluster and I want to test it quickly and I don't want to break other people who might using the environment, I want to do it locally, but to get it locally, it would mean to run all those 8 components in some Docker compose or somehow get it there, and I would have to import database and all those kind of things, which is also not very easy. So I will make my laptop as a part of the mesh, as a global mesh. So he will join the mesh, and I just, in my local laptop, I will make a feature and I will send 50 or 20% of the traffic of the product catalog service to my laptop. So that is my goal. So to recap, what you will see now in my part is, first I will make a change on my laptop. Then I will run it locally from my IDE. I will use a Visual Code Studio. And then I will make it available in this cluster. So it will be behaving like it is running locally. And I will do some real tests. So now let's go into the demo part. So first, what I am having here is my EKS Kubernetes cluster. This is what I want to show you with my namespace, and I am running my pods, each one replica with each pod, and all these services. So this is my hipster shop, and this front end is exposed on the public network. So I'm having here, I put it for the purpose of this. I made a DNS record on the floating IP of the egress gateway. So now if we refresh, this is the hipster shop. So it has some features like card, currency. So I can do all these things, and it is running publicly. Now, before I make any changes, let's take a look how it looks from the developer view in our console. So I can go here and as a developer, I have access to development namespace. So this is the place where I have access. Then there are other environments, but I can see only development environment. And currently, I am having 2 sites. So one site is my EKS cluster in AWS. And second, I make my site as a laptop. So this is my local laptop, which is also running as a site. So currently, there is no traffic between my laptop and EKS cluster in AWS. And if we look on what is actually running in my namespace is yeah, I forgot to generate traffic. Like Madhukar, can you generate me traffic?
Yeah, I will. Yep.
Yeah, so I would show you the topology, but it will take, people need to make some requests. So the topology is real-time generated. So never mind, we can proceed, and we will see it in a few minutes when Madhukar will generate some traffic on the public endpoints, but we should see how those services communicate each other. I have window here for, maybe we can do last 1 hour. Yeah, last 1 hour will work. So if you look on last 1 hour and I zoom in, we can see that I am accessing the front-end service. And then from the front-end service, it goes to recommendation service, advertise, and this is our product catalog. So these services are actually, we are reading it and visualizing it from the Kubernetes services. So all these services, as they are in Kubernetes, you can see here the traffic communication, the requests, you can see individual lines, like where, for instance, product catalog talks to each other. So we have now nice real-time visualization where we can change the time frame. Now, what I will do is I want to change this product catalog and I want to serve it partially from my laptop. So what I have here is my Visual Code Studio, where I have product catalog service source code, and I can either modify code or this product JSON is basically showing the list of the items in the eShop. So here, if I click, you can see vintage typewriter. If I go back and search, you can see this is the content. So I will just change this to CNCF. And now I will not actually build any Docker image, nothing, because I'm just developer. I just want to test it. So I will just do go run server go, which just compile Go-based application, and it is running on my laptop. And now I will go here, and in our management under routes, I will just say, I want to send in my destination, I want to send 50 and 50%. So right now you can see I'm sending all the traffic to product catalog service in the EKS. If I change it to this, I will start sending half of the traffic to my laptop. So let's make a change. And now, can you see? Now here is CNCF. If I will be refreshing, let me refresh a few times. I don't know why I'm hitting. See, now I hit the vintage typewriter. Now I CNCF vintage. So it's almost, it should be 50% of the traffic. Madhukar is probably generating some other traffic, so it is doing actually more. So you can see I am serving half of the requests on the global public endpoint from my laptop, and only thing what I had to do is go run. Now if I go back and I show a little bit how it works. So I have this route which I show you that product catalog has two clusters, and they are actually served by endpoints, where in the endpoints I am serving product catalog here as a Kubernetes service. So we can take a look. So this is, here I'm saying like Kubernetes, and this is my service name. So this is the service name in Kubernetes and Kubernetes namespace. And the second endpoint is just IP address. And this IP address is actually my IP address on my laptop. So this is, my endpoint is represented as an IP address, and I am using the port because go run is the product catalog is listening on this port. Now, if we go to service mesh, now let me refresh. So now if I zoom in, you can see that here and here, this is the product. This is my laptop, IP address of my laptop, and this is original product catalog. So you can see that it is working, and front end and recommendation service, they are talking to both product catalog in the EKS cluster as well as my laptop with this IP address. So you can see this graph is real time based on the traffic, and it's very easy, and it would be extremely hard to get all these services on my laptop and make sure that they have all databases populated and they communicate to me. This way, I am just one of my laptop, which is actually even in different continent because I'm sitting in Prague, and this is running in US, and it behaves like there is almost no difference, and nobody will realize that traffic is that service is served by my laptop locally. To give you last proof is that if I kill this and I will do the refresh, you can see now it's failing because I stopped my app. We can also configure health check. So if the health check doesn't work, it will not be serving the content. I just wanted to show you that it's real. If I refresh, it should come up again. And this is all from my part. So I will transform. This was the developer role. So just to recap, I make a change and then I make it visible to the global network. And now let me pass the ball to Madhukar, who will continue as a DevOps and SecOps guy.
Thanks, Jakub. That was awesome. So just give me a okay once you can see my screen, Jakub.
Yeah, I can see the terminal and hipster shop.
Okay, got it. So yeah, so until now, Jakub was actually playing around his development environment. He has a dev cluster which is running on AWS. He did something locally, and he maybe has added new features, or he's basically added more APIs. And now, as a DevSecOps admin, I actually want to understand what are the different communications happening between each of the services, right? I need to understand that visibility. So once I understand that visibility, I want to create like maybe a whitelist rule to enforce that, right? So for example, let's say like if nothing was enforced, no rules is enforced, then for some reason one of the service was got hacked, and it is exposed to a hacker, and then we need to limit that footprint. So if email service is the more like a so like it's only consumed by front end, and email service doesn't have to talk to anybody else, then we need to block that communication so that we can reduce the footprint. So just to understand that visibility and then enforce that policies is really important for a DevSecOps admin. So, and then usually they will have three clusters. One is a development cluster, a staging cluster, and a pod cluster. For this demo, we are just showing two, but could be many. So usually a SecOps admin would learn everything maybe from a test environment and want to basically dynamically learn it and also enforce it across multiple environments. Like Jakub added a new feature which may have created a new API endpoint communication between two of the services that a DevSecOps admin would want to know and would want to enforce this policy across the second cluster. So what I'm going to do as part of this demo is I'm going to show you how we are going to discover new and existing API endpoints. I'm going to briefly talk about what I mean by when I say API endpoints. Initially, I am going to just do it for the development cluster. And then once I discover it, I will use APIs to basically secure that as well. So when I say secure, it is nothing but it is creating a bunch of application policies to enforce that whitelist rules or to enforce that API kind of RBAC. And once I do that, I really want to enforce the same set of rules also on staging. So this way you can understand that we can learn the API endpoints from one cluster and easily enforce it on another cluster. So next, I will actually log into Altera's console and then walk through as a DevSecOps admin. So this is the system namespace view. We are actually running around close to 130 to 140 Kubernetes clusters, and you can actually see the health of that cluster. Some of them are bad, but most of them are up and running. So you, as an admin, you can go and filter these sites by label. So I have created a new label, which is key as demo and the value as CNCF. Now it basically is pointing to three Kubernetes clusters, one for this is hipster stage, this is dev, and this is, I guess, Jakub's laptop. And then if you click on each of this, you get a brief overview of what's the health of that particular site and how's the connectivity looks like and what's the input and throughput. And then you can click on explore site and get more detailed information of everything what is happening on the system, which usually a system admin or a SecOps admin would want to know. Like he can look at the denied rules hit tile here, and then there are system metrics, all the alerts related to this, and what are the interface, how is the interface doing, what's the throughput, how's the data coming in and going out, and also related to application metrics. And we can actually deep dive onto those system metrics and maybe try to compare from the input throughput to output throughput and try to make some relationship between why is it happening. So just to have all these kind of metrics is really important. And then there are many more, like for example site status, to make sure what operating system you're running, what's the software version you're running. And then we have details like, okay, what's the alert, the request, which are hitting this site, and much more details. Now this is more for a system admin who can come in, look at this site, health of the site, and do more things. As like you in previously when Jakub showed, he had only access to one cluster, which was CNCF hipster dev, because he was admin to that cluster. But as a system admin, I have access to all of the application namespaces. Now what I'm going to talk about is I'm going to uh, briefly talk about what do I mean by API endpoints, right? So just give me a second, let me reload this. So API endpoints is nothing but like there is a service A, for example, all the like you can think about all the clients which are hitting this front end. So client is kind of the source, and then we have the destination service. So this is the these are the API endpoints through which they are consuming it, right? So this is the URL and these are the methods, and then there are much more information. We'll not go into that, but this is critical important information which you need to know. So now if you know between, okay, what are the collapsed URL and what are the what are the method, then you exactly can create a whitelist rules for that. Jakub, can you make sure that you bring up your laptop environment up so that we can run the demo?
Yeah, he is up. He's up.
Okay, thanks. So yeah, so this is critical information, and it's just not that. What you can also look at is, okay, where are my services running? Okay, and who is accessing it? You can see Jakub's laptop, and there are a few other services who are accessing this front end. You can look at the request, the metrics related to it, the request related to it. So every layer, you should be able to see what's happening. That is basically giving you the control of, okay, like what was wrong and what's going fine. Okay, going back to the demo. Right, so now, so what we have done is we have created a small tool. It's a wrapper tool which is using Volterra's APIs to basically query the data service to get all the API endpoints. So this table basically is showing you who is the client. For example, there's a front-end client, and then there is a currency service which is acting as a server. So front-end clients or currency service is talking over HTTP method post, and these are the paths which they are using it. Now, this is all critical information, not just for developer to understand. Let's say he's consuming some third-party service, or he's doing some third-party integration, or consuming some of the publicly available SaaS service. So this is critical for him to know so that he can make the feature development, or he can add more test cases, try to understand what is happening. Just having the visibility is really important. Now, it's just not for two of the services. For the entire app, we have this kind of a map which shows what's the client, what's the server, what's the HTTP method, and what's the URL, right? So now what I want to do is I want to actually create the whitelist rules. So what we have in Volterra is we have a concept of service policies, which are nothing but application level policies where you can define services using labels, and then you can just say, okay, what's the collapsed URL, or what's the path, what's the method, and then you can create rules to allow or deny it. So this wrapper script is going to do the same. So I'm going to apply this. So as you can see here, right? So it's basically creating these policies. It is making sure that the right paths are being associated with those policies. And then it's just not for one services, for entire app you have these policies. Now I was basically showing you just one application. Let's say that you have categorized into 3 different applications, and then you have so many microservices under each of the application. So you can do it at per application based as well. So we have something known as app type, which you can define in a way that app type 1 represents application 1 and app type 2 will represent application 2. So you can dynamically do it for multiple applications on the same Kubernetes cluster as well. So yeah, so what has happened here is it basically has created all these rules. And then now if we go to the Hipster Shop app, we are able to access it like we have before. We are able to view the cart and everything is fine. But if you try to access anything else, 1 second. So we'll just give it some time just to show what kind of policies we have applied here. So you can see all the different service policies or service policies rules which we have created to allow the communication. So anything else should be denied. As you can see, right? So the cart is at the appropriate endpoint path and it was working. And then as soon as I have entered cart 1, which is not a valid path, which was not learned, and hence it is denied right now. Now, what we have done before was we basically showed you the discovery for the of the hipster dev cluster. And then what we are now going to show you is basically how we can apply the similar policy, learn all these API endpoints from one Kubernetes cluster and apply it against another cluster. So that's what we're going to do right now. So before we do that, what I want to show as a before this step, what I want to show is right now, email service is one of the service we shouldn't have access to, basically adding a item to a cart, but it is able to do it right now because we don't have appropriate policies on the staging cluster. So if you see, what I'm trying to do here is I'm trying to add a product to the cart, and this email service shouldn't have access to do that, but he is able to do that. As you can see, the front end service is basically redirecting 302 is basically redirecting it to the cart service, and this worked fine. So this came up fine. This is a problem right now. So what we want to do is we want to reduce this footprint of the attack when email service is basically hacked by somebody. So we're gonna apply similar application policy rules onto staging cluster as well. So I'm just going to change the policy namespace to CNCF hipster stage that indicates my staging cluster, and I'm going to apply the same policies. So it's the same process. Whatever API endpoints we actually learned from a development cluster is getting applied onto the staging cluster. And all of these are actually same API endpoints. Nothing would have changed. You can actually control that using the range from where you want to dynamically detect. So right now I'm giving last 10 hours. You can say, okay, last 10 minutes or 1 hour. So you can have that variable or the step size. Now let's run the same command. Okay, now as you can see, after we have applied the policies, this communication is blocked, and this is really needed to basically reduce the footprint of that attack. So we exactly know what service talks to what service and what API endpoints it is using, and then we can limit to that. So this basically completes the demo, and we are now at the end of the presentation. So we are now, I think we are open for any of the questions you have.
Yeah, and just a friendly reminder, if you do have a question for our presenters today, you can submit your question through the Q&A box at the bottom of your screen. And it looks like we do have one question in there, Madhukar and Jakub. Do you want me to go ahead and read it out loud for you?
Yeah, I see it. Can we get the number of API calls? So definitely, right? So what we are doing is, if we have a request session where you can see all the different requests which are coming to per API calls. So let me share my screen and quickly show that. So if you take any service, for example, let's say let's take the recommendation service. You actually know what are the different requests which are coming in onto this service. So this is a bit sampled, but definitely like everything is known. Like for example, if you had a 404, if you had a 503, or if you have some 4xx or 5xx error, everything is known here. So you would definitely, and then you also have per edge. Like for example, you can go to the each of the edge and then find health related information. So let's say we'll go to the health, and we can see what is the request rate, what are the error rate, the throughput, the latencies, everything what you need. And just not this service as acting as a client, but also this service as a server. You can see it here. And then there are metrics tools which you can use to basically look at it in a granular way. Hopefully that answers the question.
Yeah, and it looks like we have another question from Nuno. It's, can you see the denied requests?
Yes, we can see the denied request as well. So if you go to the error rate, then you can see that the 404 error is getting increased. That we can see from this service mesh graph.
Great. Well, I think that those are all the questions that came through. We'll just give a few seconds here for any last minute questions. Okay. Well, thank you again, Jakub and Madhukar, for a great presentation today. That's all the time that we have. Thanks again to everybody who joined us. Just a reminder that the recording and the slides will be available later today on the CNCF website. We look forward to seeing you all at a future CNCF webinar. Have a great day and stay safe. Thanks, everyone.
Thank you.
Thank you.
Bye.
Bye.